This is FRQ on number one on the final review. Okay. So f of x equals piecewise rad x plus 1 from 0 to 3 and 5 minus x from 3 to 5. And we want to know if f is continuous at 3. What does it take for a function to be continuous? Not just that. The limit from the left, the limit from the right, and the function's value have to be equal to each other, right? So we're going to find the limit as x approaches 3 from the left of f of x. And what's that equal to? Rad 3 plus 1, which is equal to 2. Okay? Because this is a function, so we're not looking at, if we were doing plus or minus, it would be both. We don't want that. Okay? So the limit as x approaches 3 from the right of f of x is equal to, because 5 minus 3, which is 2. So what can we say at this point? Therefore, the limit from the left is equal to the limit from the right. Therefore, no, the function is not continuous yet. The limit exists at 3. The last thing we need to check is f of 3. F of 3 is using which part of the piecewise? The top, so it's going to be, again, radical 3 plus 1, so that's going to be 2. So the justification for part A is, or the answer, first of all, is f is continuous when x equals 3, since the limit as x approaches 3 from the left of f of x equals the limit as x approaches 3 from the right of f of x equals f of 3. So that is part A of number 1. You guys okay with that? Pretty easy, wasn't it? Yeah. I think. Part B, it says, suppose the function g is another piecewise function. Aha! I see k and m. It says where k and m are constants. G is differentiable, which means what? We can take derivatives, right? G is differentiable at x equals 3. What are the values of k and m? In order for g to be differentiable at a point, what does it mean for a function to be differentiable at a point? Has to be continuous. That means the left and right hand derivatives have to be the same, right? So let's just show continuity. What's the equation for continuous? K rad, but we're looking at specifically x equals 3. So k rad 3 plus 1 is equal to the other function. So it would be m times 3 plus 2. And then we'll simplify that a little bit. What's rad 3? So that's going to be 2k equals 3m plus 2. We'll leave that equation where it's at for right now. The next part of differentiable is that the left-hand derivative equals to the right-hand derivative, right? So the first thing we have to do is find the left-hand derivative. So what is the derivative? How do I want to say this? The notation isn't very good on this one, but we'll say f prime of x from the left of 2. Well, this is the best way of saying it. I'm not going to be too picky on this, but the limit as x approaches 3 from the left of g prime of x would be the best way to approach that. Okay? What is the left-hand limit? Function right now. Function. K rad 4. Wait a minute. What? We got to find the derivative.
Well, it's k x plus 1 to the 1/2.
So let me rewrite the function. Or let me rewrite k rad x plus 1. We're going to rewrite that as what? K x plus 1 to the 1/2. And this is where a lot of you guys screwed up on your last quiz. What's the derivative of that if k is a constant? 1/2 k times x plus 1 to the negative 1/2 times 1, okay? And then we're going to plug in 3. So 1/2 k times, oh, let me rewrite this real fast. This is going to be k over 2 rad x plus 1. And now we'll plug in 3. So k over 2 rad 3 plus 1, which is, let me write it here, k over 4. That is the derivative from the left. Now we need the derivative from the right. So what would the derivative from the right be equal to? That's easy. M. Right? Because the derivative of a constant times x is the constant. So what do I do with the left-hand derivative and the right-hand derivative? So we're going to say k over 4 equals m. Now what? Now we're going to take these two values, or these two equations, and put them together. Since this is equal to m, what's this going to say up here? 3 times k over 4 plus 2. So 2k equals 3k over 4 plus 2. Just to make my life easier, I'm going to multiply everything by 4. So I don't have fractions to deal with. So I get 8k equals 3k plus 8. 5k equals 8. So k equals 8/5. And we need to find m. So we're just going to plug that in here. So it will be 8/5 over 4 equals m. So what's that? Wow. Okay, let's go back to divided by 4, right? How do you divide fractions? Put it over 1. 8 over 5 times 1/4 equals m, so it's going to be 2 over 5. And is that all it wanted? What are the values of k and m? So m is 2/5, k is 8/5.